Okay, so in gram-gram stoichiometry, these have been three-step problems. The first fraction of the three steps helped you to convert a mass in grams to moles of that substance. So that first fraction, which was grams of a substance, took you to moles of that substance. And this is where you had 1 mole over some number of grams that came from the periodic table. Okay. The second fraction took you from moles of that first substance to moles of the new substance. So moles of the old substance to moles of the new substance. And these numbers came from the balanced equation coefficients. The third fraction took you from moles of this new substance to grams of this new substance. So here you would have had 1 mole of the new substance having some number of grams of that substance, and of course that comes from the periodic table. So gram-gram stoichiometry was when you had mass of a substance and you had to convert it to mass of a different substance. So for example, if we have this equation here, 2H2 plus 1 O2 turning into 2 waters. If you started with 64 grams of oxygen and I asked you to find the number of grams of hydrogen, you would set this up as a problem in the usual way, 64 grams of O2. The first fraction, grams of O2 goes in the denominator, 1 mole of O2 goes in the numerator, and from the periodic table, the mass adds up to 32 grams. So this first fraction converts grams of O2 to moles of O2. If you stopped the problem here, since grams of O2 cancel, your unit now is in moles of O2. But we're not trying to find moles of O2, we're trying to find grams of hydrogen. So now that we are in moles of O2, now we can use the coefficients, which represent a mole ratio, to convert from moles of O2 to moles of hydrogen. So the middle fraction, we'll put moles of O2 in the denominator, so it will cancel, and moles of H2 in the numerator, because that's what we have to convert to hydrogen. So the coefficients from the balanced equation, this mole to mole ratio, 2 from right here, 1 from right here. If we were to stop the problem right here, moles of O2 cancel, and our unit, if we stopped here, would be moles of hydrogen. But we're trying to find grams of hydrogen. So one more fraction, moles of H2 in the denominator, grams of H2 in the numerator. This is a periodic table, molar mass. 1 mole of H2 is 2.0 grams of hydrogen. So here at this point, moles of H2 cancel, and we now have grams as our unit, and so the math, 64 divided by 32, which is 2, times 2, which is 4, times 2 again, which is 8, okay, to 3 significant figures, because 64.0 was 3 significant figures, and we'll have 8.00 grams of hydrogen. Okay, so that's that's gram-gram stoichiometry. But now I'm going to introduce some problems to you which are considered to be variable stoichiometry, meaning that you will use fewer than the 3 steps. Okay, so here's the thing. If I had given you the number of, if I give you grams of the old substance, the original substance, not old, it's not old, it's original. Okay, then you're starting out with the first fraction of the 3-step problem. Okay, if you're given grams of original and you have to go to moles of the new substance. Okay, think about that in this 3-step problem. If I give you grams of the original, like let's say I give you grams of oxygen right here, and I asked you not to find grams of oxygen, but I asked you to find moles of oxygen. Okay, in this case, you would do 64.0 grams of oxygen And it would still start out, this problem would start out the same way. 1 mole of oxygen weighs 32 grams, so right now this first fraction converted grams of oxygen to moles of oxygen. We would then set up the second fraction, which would convert moles of oxygen to moles of hydrogen. And so this is the coefficients 2/1. This problem stops here. If I give you grams of the original substance and I ask you to find moles of the new substance, that's here, that stops here. Everything else is going to cancel. All right? So in this case, you would have 4 moles of H2. Okay? So if grams of original is given to you and you have to find moles of the new, you're doing the first 2 fractions. But what if you are given moles of the original and I asked you to find grams of the new substance? Okay. Well, in this case, this is effectively like I've done the first fraction for you, because remember the goal of the first fraction is to give you, it converts grams to moles of that original substance. So if I give you moles of the original substance, I've already done the first fraction for you. So in this problem up above, if I didn't give you grams of oxygen, if I gave you 2 moles of oxygen to start with, okay, you don't have to do this first fraction. It's already converted to moles, so you wouldn't do this first fraction in this problem. You jump right to the second fraction, which is moles of O2 in the denominator and moles of H2 on the top. And those are the coefficients from the balanced equation. Okay, you would continue on with the third fraction, the third step, which is moles of H2 to grams of H2, because that's what you're trying to find, is grams of the new substance. And so that's periodic table. Okay, so here in this case, you have 2 moles times 2 times 2, giving you 8.00 grams of hydrogen. Okay, so be careful when you're reading these problems that you know where you're starting and you know where you're going. There's not always going to be 3 steps. Okay, so let's take a look at this problem on problem set number 3, number 1.